Okay, this is actually a question that I haven't done yet, but it was the question of the day, so that's why I picked it today. The game is basically you generate a random number in the interval from 0 to 1, and you can generate additional random numbers as many times as you want for a fee of 0.02 per generation. This decision can be made with the information of all previous values that have been generated. Your payout is the maximum of all numbers you generate. Under the optimal strategy, find your expected payout of the game. So basically, this is very similar to a question that I did a couple of days back, but the only kind of difference to that is that this in this game, you kind of can base your strategy off of what your previous row is, whereas in the previous question, you kind of don't know. So you just first determine how many rows you want to do, and then just row it. Whereas here, you can do it progressively. You row one, see the value, and then decide. So in this sense, we kind of have a bit more freedom with what we want to do. So essentially the idea is, okay, we're definitely going to try to find an expected value for when we're going to stop, right? Obviously going to find this expected value. So if our value is higher than this, we're just going to automatically stop. And if it was lower than this, we're going to keep rolling until we get to this value. And then our actual value of the expected number generated in the end will be slightly above our expected value of our strategy because there might be the chance that for the cases that we get something above that in the first row, then it would have been slightly higher. So it'll be slightly higher than expected value, but still close to it. So that would be kind of the strategy. So how we're going to do this is we're just going to determine first the stopping threshold. So each generation costs 0.02, and then we're just going to assume that up to this point, our maximum value that we've drawn is x. And then we have a new number that we're going to draw that we're going to call y, that is from 0 to 1, obviously. That's uniformly distributed as the problem states. So we're looking for our maximum, right? And we're only going to do this logically if it gives us a good marginal benefit for doing this. So at the end, when the marginal benefit becomes 0, then we're going to stop at that point. So the expected marginal benefit would just be integrating from x to 1 of y minus x dy. This is because to increase the maximum of a single draw, we kind of have to minus the expected value of the y from the current maximum x. So this comes out to basically, okay, if we're going to integrate this, then for the x values that are from x to 1 that is bigger than our current x, the marginal benefit is y minus x. So yeah, we're just going to integrate this. This would just be this, so then it would just be 1 minus x squared divided by 2. And then, yeah, basically it's just what I explained. Basically, only if the marginal benefit is good enough, worth the 0.02, will actually play the game. So I'm going to set this to 0.02, just arrange the equation. I'm going to find out that my x is 0.8. So this e over here of my strategy would be 0.8. So anything lower than 0.8, I'm going to pay the cost and play again. And if it is higher than 0.8, I'm going to stop and take what I have. So then I'm going to calculate my final expected payout after this, right? So if my value, I have my first game. When the first game starts, I have my first free spin of the number. So I'm just going to call that y. If that y1 is greater than or equal to 0.8, then I stop immediately and my payout is just that number. If it's the case that it was less than 0.8, I'm going to play again and again. And my expected value from playing over and over again, drawing, would just be 0.8 because if it was greater, then I stop. If it was lower, I continue. So then my expected payout from this would just be 0.8. So that I could just break it down into the two cases, right? If the first spin was from 0 to 0.8, so that's when it's less, then my expected value would be 0.8, and then that would just be my integral of that. And if it was from 0.8 to 1, then it would just be the payout would just be that y. So I'm going to evaluate the integrals, just do a bit of calculation, and it lands me at 0.82. So my expected payout would be 0.82. So the idea behind this essentially really boils down to, okay, I'm going to try to find this expected value of my strategy playing the game. Like what is like this threshold for stopping. And then once I determine that threshold, I finally calculate my expected value from earning that much after that. Yeah, end it off here.